So if we take a look at this kind of first section, we're going to talk about some important definitions. One is a monomial, which is just a one-term expression that is a number, a variable, or a product of a number and variable. I'm going to write down a couple examples. One example could just be 5. Monomial. It's a number. Could just be a variable, so I can just say x squared. That's a monomial. And another example could be a product of a number and a monomial, like 7x to the 4th. Give me another example. Megan? 11. Yeah, 11. That's a monomial, just a number. The other example? This is a variable. X squared. All mono. 11. X squared. Those are all monomials. It's just a number, just a variable, or a number with a variable. Okay. All monomials. Nothing's being added or subtracted, essentially. One thing. A polynomial is either just a monomial or the sum of many monomials. The stems of this word breaks down to mean many terms. Okay. Well, some examples of a polynomial are x squared plus 5. Number 1, 3x squared minus 7x plus 2. Okay, essentially polynomial, you're just taking monomials and adding them or subtracting them. So give me an example of a polynomial based on what we wrote. Aiden?
1 plus x to the 4th plus y squared.
There we go, perfect. 1 plus x to the 4th plus y squared. That could be a polynomial. Bunch of terms being added or subtracted together. Questions over there. So monomial is one term. Polynomial is multiple terms being added or subtracted. The standard form of a polynomial function arranges the terms in descending numerical order. Based off the powers, not the coefficients. So essentially, when you're writing something in standard form, you're going from biggest exponent to smallest exponent. Has nothing to do with the coefficients. Always just the exponents. Okay. The degree we talked about yesterday, the degree of a polynomial is the very good, biggest exponent. Of any monomial term. Questions over kind of vocab section. Okay. We can classify a polynomial by its degree or by its number of terms, and we're going to see that in this table below. Okay. So in this first row, we have something with a degree of 0, and we would call that, if it has a degree of 0, it's called a constant. An example is just any number, 5. So if it has a degree of 0, the polynomial is just a number. Any number has a degree of 0. Okay. The number of terms, well, how many terms does 5 have? 1. It's one term. It's the only thing there. So that means we would call it a what if there's only one term? Monomial. A polynomial with a degree of 1. Kind of look at an example. If we were to graph that example, we would get a straight line. So what kind of math word sounds like a line? Melvin? Yeah, linear, very good. The polynomial with a degree of 1 is linear. And the example is just x plus 4. Meaning the exponent, the largest exponent here with the x is a 1. So that will make it linear. How many terms are there? 2. And it has 2 terms. And remember what it's called? Very good. A binomial. The monocycle has 1 wheel. So there's a unicycle. A bicycle has 2 wheels. So a binomial would have 2 terms. A polynomial with a degree of 2. Does anyone know what that's called? Good example. We dealt with a lot of these this year. That is a square. There's a formal name for that. This 4x squared. You're on our track with a square. We dealt a lot with these types of functions this year. Starts with a cube. Yeah, quadratic. Good. So, a polynomial has a degree of 2, meaning the largest exponent is a square. Is a 2. We call it a quadratic. So how many terms are there in our example? 1. So we would call that a monomial. Anyone know what a polynomial with a degree of 3 is called? That's it has 3 terms. So you're right, it has 3 terms. It's a trinomial. Does anyone know the special name for if you cube it? We call it a cubic. Oh, very close. A cubic. We call it a cubic. And the highest exponent is a 3. So we look at an example. Our highest exponent is between 3, 2, and 1 is 3. So it would be a cubic. How many terms are there? 3. So as Josh and Megan were saying, we would call this a trinomial because there's 3 terms. So a bicycle has 2 terms. A bicycle has 2 wheels. A tricycle has 3 wheels. So a trinomial would have 3 terms. Anyone by chance know what a 4th degree polynomial is called? It is called a quartic. 4 quarts in a gallon, 4 quarters in a dollar, quartic. That's a degree of 4. Meaning the highest exponent is a 4. Okay. How many terms are there? 2, so we call this a binomial.
We have to remember all these.
Yeah. Just more like the degrees. So constant, linear, quartic, quadratic, cubic. Those are more what you have to remember. Anyone know what a polynomial with a degree of 5 is called? What is it? Perfect. It is a quintic. Very good. Meaning the largest exponent is a 5. How many terms are in this one? 4. When that happens, when anything over 3, we just call it like a 4th term polynomial. If it had 6 terms, it'd be a 6th term polynomial. 7 terms, it'd be a 7th term polynomial.
What about the 5?
Be a 5th term. Anything over 3, which is whatever term polynomial. Big thing is quartic and quadratic get flip-flop because they look very, very similar. Quadratic is 2, quartic is 4. Okay? Nothing on that. what we're going to do, we're going to arrange these polynomials in standard form, state the degree, and then classify them based off their degree. So when you arrange it in standard form, remember it goes from biggest exponent to smallest. So if you look at number 1, which one has the bigger exponent? 9. It has 9x squared. That's the bigger one. That's going to go first. I like to cross it out. I know I'm done with it. Between 3x and 5, which one has the bigger exponent? 3x. Good. Because that has an exponent of 1. 5 has an exponent of 0, or a degree of 0. So it goes in the back. The number, the constant, always goes in the back, no matter what. Regular old number will never go in front of a term that has a variable. Okay. Well, what's the degree of this polynomial? 2. Very good. The largest exponent is a 2. So if the degree is 2, we call this a what? Okay. And number 2, we're going to arrange these in standard form. Again, biggest exponent to smallest exponent. Which is the bigger exponent? Yeah. X to the 4th. So that's going to go first. I'm going to cross it out. 4 is the biggest exponent. What's the next biggest exponent? 10x squared. But isn't there another x squared? It's negative 6. Yeah, but what did they say about coefficients? Do they take part in the order? Only the exponents. So if you notice how these both have x squared, so what do you think we can do with them? Combine them. So when that happens, they're like terms. You just combine them. So what's negative 6x squared plus 10x? 4x squared. So that's going to go next. So you can combine them. Go for it. Make sure you combine them. What's the next biggest one? 4x. 4x. Very good. And then what's going to go last? Minus 12. Perfect. And make sure the sign follows the number. So how the 12 negative, so the negative is still going to go out in 12, in front of 12. The 4x is positive, so a plus sign is going to go out in front of the 4x. Make sure the sign follows the term. Okay. Well, what's the degree? 4. Good. And if it says a degree of 4, how would we classify this? 4. Okay, if we arrange 3, which one's the larger exponent? 3x cubed. Cross it out. Which one's the next biggest one? X. Make sure the sign follows the term. And then the plus sign is going to go on the back. What's the degree? Largest exponent is 3. And if it has a degree of 3, how do we classify it? Cubic. And the last one, which one's larger? 2x to the 5th. So pretty much they just trade places. And then the minus 4x squared goes after. What's the degree? 5. If it has a degree of 5, we would call this a quintic. Questions over there? Right? And this next section, we talked about this a little bit yesterday. We're going to talk about the end behavior and the degree of a polynomial. The degree of a polynomial is one of the most important things we can know about it. It tells us a lot of information. Okay? One thing it tells us, it pretty much tells us what the graph's going to look like. It's going to tell us the end behavior. Okay? By just knowing the degree, we can figure out what the ends of the graph are going to look like, what direction they're pointing. We can also know, if we know the degree, we know the maximum number of turning points. Okay? So how many times the graph changes direction or how many curves there are in the graph. We also know that from the degree. And we can also know the number of zeros or solutions. Or x-intercepts. All three of them are the same. Both real and imaginary. We know how many there are. Just by knowing the degree. Well, first we're going to take a look at how the degree can tell us the end behavior. Okay? Again, end behavior is just what it looks like at the ends or the arrows of a graph. And there's 4 types of end behavior. We're going to take a look at all 4 below. First, going to label each with appropriate degree. State whether or not the leading coefficient is positive or negative, and then use that to state the end behavior. So look at this first one. What's the degree? It was just x squared. 2. The only exponent. 2. And is that positive or negative out in front? Positive. So the A, the number out in front, is positive. And what do you notice about the graph? It's pointing where? Up. Yeah, the left side is pointing up, and the right side is pointing up. Okay? So, down here in these boxes, essentially, when it's saying x is going towards negative infinity, that just means the left side. The left side of your graph. Okay? And if we look at the left side of our graph, where's the arrow pointing towards? Yeah, it's pointing up, which is towards infinity. Right? And when you have positive infinity, that just means the right side. So you go to the right side of your graph. Where's the direction is that arrow pointing? Up towards infinity. Okay. And that's going to be true for any single even, positive function. The end behavior is always, both ends are always going to be pointing up towards infinity in the y direction. Okay, every time. So take a look at the next one. What's the degree of this polynomial? 4. And is this a negative function or a positive function? What's out in front? Yeah, there's a minus sign out in front right here. So it's negative. So let's take a look at the end behavior. And again, negative infinity, that just means left, and this side just means right. So to the left side of our graph, where's it pointing towards? It's pointing negative infinity, pointing down towards negative infinity. And what about this side? What about the right side? Same thing, it's pointing down towards negative infinity. So look at the next one, the degree. What's the degree of the next one? The degree is 3. And it's positive. So again, if we look at the left side of our graph, let's look at the left side. Where's it pointing towards? Up or down? Down. Towards negative infinity. And then we look at the right side of our graph, pointing up towards infinity. Okay? And that is true for any odd positive function. So the left side is always going to point down, the right side is always going to point up. Every time. What's the degree of this fourth one? So it's 3. And is it a negative function or a positive function? Yeah, there's a negative out in front. So on the left side, it's pointing up towards what? Good. Positive infinity. And on the right side, good. Pointing down towards negative infinity. So for any odd function with a negative out in front, that's what the end behavior is always going to be. The left side is always going to point up, and the right side is always going to be pointing down. Okay? These end behaviors are are true every single time. Now, there might be a different number of curves in between, but generally speaking, that's what the end beginning will be. Okay, questions over that? So we can see, I'm going to copy and paste it so you get a better visual with our graph. Okay. So it looks like for our even degree functions, the arrows both go towards either positive infinity or negative infinity. Okay? They're going in the same direction essentially. They're either both pointing up or they're both pointing down. If it's even. The leading coefficient is positive. The arrows go towards which direction? They both went towards positive infinity. If it was negative, they both went towards negative infinity in the y direction. That's true every single time. So if it's positive out in front and even, it's always going to point up towards positive infinity. If it's negative and even, it's always going to point down towards negative infinity. You don't even have to plug in your calculator to know. You can just look at the type of function and the degree. If the degree is odd, one arrow goes towards positive while the other one goes towards negative infinity. So essentially they're going in opposite directions. One's pointing up, the other's going to be pointing down. Okay. If it's positive, if the leading coefficient is positive, the graph has a what? Which one did it start with? Yeah, it kind of had a down up trend, right? It pointed down, and then it went up. So it's pointed towards negative infinity, and then it pointed towards positive infinity. And then if it's negative, it flip-flops. So it went up, down. True every single time. Questions over that? All right. Turning point. This is how many times the graph changes direction, or kind of all your curves in your graph. For each of the following degrees, sketch a graph describing the possible number of times it can change direction. So if it's linear, what kind of graph is it going to be?
A line.
Yeah, straight lines. Are there any turning points? No. This is a perfectly straight line. So there's zero. Zero turning points. What about quadratic? What kind of shape is the quadratic made? Yeah, new shape. So how many turning points or curves does that one have? One. And again, graph, draw any kind of quadratic you want to. That's mine. That's one turning point. Does that have an idea kind of what a cubic would look like? It has, well, how many curves is it going to have? Two. Yeah, good. It's like kind of like a snake. Kind of like, there we go. Something like this. Sometimes it might look something like this shape as well. It's not as distinct, but there's one curve, two curves. So there's going to be two turning points. How many turning points would a degree of, four have? Yeah, that's a degree of 4. It's going to have 3 turning points, and it might look something like this. Or, could be like this. It kind of snakes like a cubic, and then it kind of curves up like a quadratic. It might look something like that. It still has 3 turning points. There's 1, there's 2, and then there's 3. We talked about this yesterday. The maximum number of turning points is what? Equal to less than the degree. So you can think of it as it's whatever the degree is minus 1. So the degree is 7. How many turning points is it going to have? 6. Not, I mean, it might have less, but it can't go over 6. The 7-degree polynomial will never have 7 turning points or 8 turning points. The most they can have is 6. Okay, questions over that? Well, number of roots is how many unique x-intercepts does a graph have? Okay? Again, the degree is helpful for knowing that. A linear function, generally speaking, how many x-intercepts does a linear function have? 1. Just kind of like that first one we drew. It's just a straight line. It touches the x-axis 1 time. Is there another scenario that it might not have 1? Will it ever have 2? No. Will it ever have 0? What kind of line? Yeah, perfect. One that just goes straight across like this. It's never touching the x-axis, but that's a linear line. It's a function, passes the vertical line test. It just doesn't have any x-intercepts. So it should have 0. What about a quadratic? How many? You can have 2, at most 2. Good. And just like we graphed on the other one, just a U shape, however you want to make it, just make sure it's crossing the x-axis twice, here and here. Okay. Is there ever a time where you can have 1? Yeah, what would it look like if it only had 1?
When it looks sideways.
If it's sideways, couldn't be a function. We're on our graph. Say it? Yeah, very good. And then on the turning point, it's the x-axis. So, oops, got a better job that one. The turning point is the x-intercept. There we go. The turning point is the x-axis. So just it comes down, touches, and goes back up. That's an example where it's 1. Could it ever have 0? Yeah, what's an example of where it's 0?
It doesn't touch the x-axis.
Yeah, perfect. It doesn't touch. It's either above or it's under. So it could look something like this. However you want to draw it. It could be opening down, and the turning point that never crosses the x. It could be above it, opening up. Questions over that? All right. We look at a cubic. Generally speaking, how many x-intercepts is a cubic going to have?
3.
3. Kind of snakes. Right. 1, there's 2, and then it comes back up for 3. 1, 2, 3 x-intercepts. Could it ever only have 2? What's an example where it could have 2? It's similar to... Yeah. When one of the turning points is a 0. So it might look something like this. There's 1, it curves down, it curves right at the x-intercept, and it curves back up. So there's 1, there's only 2. It's still cubic. Is there a situation where it can only have 1? Yeah. What would it look like if it only had 1? What about the curves? Perfect. It would go up, and when it curves back down, it just never touches the x-axis again. So that's why there's only 1. And again, it could be oriented differently. It could start up, go down, and then curve below the x-axis. Those are just some examples. There's multiple that only have 1. Would it ever have 0? Why? Not is there a bottom? It's there at the top. Yeah, it's going in both directions. So if it starting on the bottom, it's eventually going to it has to cross eventually because it's going in opposite direction. No matter what, a cubic's going to have at least one x-intercept, no matter what. Okay. Questions over there? Okay. Oh boy, quartic has a lot. So generally speaking, how many is a quartic going to have? 4. And similar to what we drew, 1, 2, 3, back up, 4. There's 1, 2, 3, 4. What's a situation where we only have 3? Yeah, the middle curve touches the x-axis. So comes up, touches the x-axis, curves, and then goes back up. There's 1, 2, 3. X-intercept. Is there a situation where we can only have 2? Yeah, what would describe that one? What would that look like? Yeah. On the curve, it could come down, it could curve, and then come back up. And there's another situation we talked about. You saw one yesterday. Sometimes quartics just kind of make this flat U shape. That's another example where it can only have 2. Kind of makes this big flat, almost looks like a flat parabola. So that's another example, just so you've seen it. We looked at one yesterday. That's an example where it has 2. What about an example where it has 1? What would that look like? Anyone have an idea what it would look like if it just has 1? Yeah, like
basically it's the one curve goes up higher, the other just touches the x and goes down.
perfect. So we might have a curve like this. It kind of snakes. It comes down. It touches the x-axis, and then it goes back up. There's 1, 2. There's still 3 curves. It's still a quartic. It only touches 1 time. Perfect. And then is there ever a part where it's going to be 0? Yeah. It just doesn't touch because it's an even degree. Everything's going in the same direction. So it might look something. Oh boy. I can't draw these up. Might look something like this. A little above. Might look like that. Just above.
Does 2 also look like this? Or just like 2?
Yeah, that's another. Yep. That could happen as well. There's tons of different. They had one where it was like this, where the 2 would only touch like twice. There's a ton of different examples where there's only 2. We're just kind of generalizing the different possibilities. So yes, you are right. So it appears the maximum number of unique groups such x-intercept a polynomial can have is equal to its degree. So it has a degree of 4. The maximum number of x-intercepts would be what? 4. Whatever the degree is, that's the maximum amount of x-intercepts it can have. There's an important note. It would always have the number of roots of its degree. So it has a degree of 4. It's going to have 4 solutions, but it might only have 3 real ones. So we look at this example right here, the second example we did, it has 1, 2, 3 x-intercepts. So that means it has 3 real solutions. There's just 1 that's imaginary. On this third graph, it only has 1, 2 real solutions. That means 2 of them are imaginary. This third one, it has 1 x-intercept, so there's only 1 real solution. The other 3 have to be imaginary. And this last one, where it has no x-intercepts, that means all 4 answers are imaginary. We'll go more in depth with that later. But essentially, it's always going to have 4 solutions. It just depends how many of them are real and how many of them are imaginary. Okay. Questions over that?